reduce delays, errors, and rework. Improved quality, since all the elements are pre-engineered, pre-constructed, they are in a well-controlled environment, which means there are control assurance and quality check is made in production facility, which makes sure we don't have any problem in a later implementation stage. It's ISO class ratings, so modular clean rooms have definitely the ability to moderate ISO class ratings, mainly controlled by mechanical systems, HVAC filtration, HVAC airflows, which are going to be described in details also in the next coming slides. So the monolithic surfaces of the cleanroom panels also allow inceptive and ongoing cleanliness, as well as affinity with most cleaning and disinfection agents and conventions. As we have sustainability is a very important fact and issue in the whole story. So we are reducing the waste with the modular construction because manufacturing process is more streamlined and precise. Everything needs to be done in a very precise details in advance. Coordination is very crucial. So materials are used more efficiently and waste is minimized. More specifically, the usage of aluminum parts also benefits the environment, as manufacturing can be done with recycled content developed to reduce waste, such as in conventional buildings use drywalls. And the drilling is often noticed with conventional construction. Our system, which we will describe, is very screwless, so it doesn't need to be cut and screwed a lot on site. So this has been minimalized. Flexibility of modular clean room offers higher flexibility to the clients in terms of remodeling and relocating the structure. So during the course of usage, the client could choose another setup of the clean room areas, and modularity enables us to redesign, remodel, to enlarge or to make it smaller, the whole operating room in this case, which we cannot do with a substructure and or conventional approach. Controlled environment management, as I mentioned before. So overall, modular clean room construction reduces labor costs. It is less labor intensive. Downtime reduces, and all other associated costs are lower in that case. Here are some examples of pictures of recently executed projects in different European countries. Those were from Germany, Switzerland, and Belgium. Here we can see how we fit in all the ductwork in the picture left above. How we do the ductwork.
The slide is not seen, Luca.
Again, not?
No, unfortunately.
Here I don't know what's. You cannot see the screen again.
Yeah, now I do. Now I do.
Now? Yeah.
Yeah, no, it's okay.
And you can see it now changing, right?
No, it stays on slide 5.
Then I will share it like that without presentation mode. So in the picture above, you can see the ductwork in place, suspended clean room ceiling, which is walkable in pharmaceutical facility. We can see different walls, lighting fixtures, doors, sliding doors, swing doors, single leaf, double leaf doors, windows, glass walls, diffusers. Those are all elements that can be supplied and installed and commissioned by our company. Here on this simple air change display, we can see HVAC setup. So from the central air handling unit where the fresh air intake happens, then fresh air needs to be filtrated, needs to be humidified or dehumidified, heated down, heated up or cooled down. And then we supply it through the suspended ceiling, through the terminal units, outlets, to the different rooms in the clean rooms. So we can see the air circulation going for extraction of the air through the exhaust grills, exhaust recirculating plenum, and then we can see through the fan filter units or diffusers. We can see the recirculating air. Partially exhaust air goes directly outside of the building itself, and partially it mixes up again with the supply air and enters the room again. So of course it's a lot better to foresee the heat recovery module in air handling unit, which enables us to get use of heat of the exhaust air, so we don't need to heat up 100% of the fresh air, but we can use the heat potential that is coming from the room, from the exhaust air. So we always have part of recirculation and part of fresh air. Fresh air is very important to maintain the overpressure in different clean areas. So this is always a game of over pressure and negative pressure. So if I go on, HVAC. Previously we had a table of particles which are shown in different ISO classes in a cubic meter. Here, very important figure that needs to be taken in account is air change rate, which means the whole volume of the room. Here we have for different classes. Let's see, completely to the right, ISO 8 class. It means 20 air change rates, 20 rates, and then you can see ISO 760 rates, ISO 680 rates, ISO 5 300 to 480 rates, and ISO 4 500 to 600 rates. What does this mean? So different clean areas have different cleanliness. 20 air change rate. Air change rate means how much air needs to be replaced every hour. So it means we calculate the volume of the room. So always take into account square meters multiplied with the height of the room. We get the cubic meters. And then we multiply this with 20 in the case of ISO 8 plus, and we get how many fresh air needs to enter again, needs to be supplied by the air handling units to the room every hour, so many cubic meters. So this means, as we can see, there is a huge difference between ISO 8 and ISO 4 plus 20 air change rates or 500 air change rates. It means even the HVAC system is a lot more complex in case of a higher clean room class. We can go on filter coverage, so the whole clean room ceiling needs to be equipped with a HEPA or ULPA filters, high efficiency particulate filters. So in case of ISO 8, 4 to 5%, up to 100% in ISO 4. So it means the whole ceiling needs to be also equipped with high efficiency filters, HEPA absolute filters. This is also, it can be, you can see how this differs from the class to class. Filter efficiency, ULPA filters U15 or HEPA filter H13 or H14, 99.997. It means in a, only three dirty particles can go through in a 10,000 particles. So it means almost all the air particles are eliminated with those filters. HVAC. What influences clean room HVAC engineering? We have different things we need to take care of. We need to make sure we, first of all, we need to define the clean room ISO classification. We always try in collaboration with the client to prepare a user requirement specification, room data sheets, where the most important things are shown, like the clean room ISO classification, the layout of the clean room, the number of people working in the room also matters, the equipment in the room, because all the equipment and the lighting is gaining a heat that we need to cool down and we need to get rid of with our HVAC systems. So pressure differential and temperature and humidity. Those are the things that we need to take care of. HVAC, we have with HVAC system we maintain different parameters, as I mentioned before. We have different types of HVAC. This I'm going to go quickly through the HVAC because we could be speaking about this for hours, but it's different to mention to aware of what is important. We have different types: ventilation with 100% fresh air, which is very costly. We need to so without heat recovery elements and modules. This is only used in environments where aggressive chemicals or toxic chemicals and substances are in an exhaust, so we cannot use this air to be recirculated again. We have ventilation with mixing of room air, which was shown before in a air display mode. And yeah, we have combined ventilation, fresh air and recirculating air. HVAC process, in order to select equipment and effectively, we need to make the configuration details, set up sizes of the clean room rooms, clean room areas. All the total volume of the air needs to be calculated on this basis. The flow rate on air terminal unit for every different room is calculated. The room parameters for each room in the clean rooms are defined. Based on that, air handling unit configuration is defined. Whether we need to humidify, cool down, or heat up the system. The air flow is defined with control volume flow controllers or variable flow controllers, constant or variable. We need to place the sound attenuators, fire dampers, And additionally, it is required to define whether only existing or newly required sources are needed. So whether we have existing hot water network, chilled water, steam, or do we need to plan and design new ones? Here are some of the most important HVAC elements that we are using for our projects. On picture number 1, you have a central air handling unit. This is for preparation of fresh and supply air for the clean room area. We have constant flow, volume flow controller and variable volume flow controller on picture number 2. So we control flow volume and differential pressure in the room and humidity. This can be controlled by this element. We have fire dampers, which are dividing fire zones in a building site, and they are protecting fire to be spread through the building in case of fire. We have sound attenuators, silencers on picture number 4, which with that item we reduce the noise pressure level of fans from the air handling unit. They can be installed in air handling unit itself or in a duct network before entering the room. So before air enters the room. Then we have FFU units, fan filter units. Those elements are for recirculating the air, which we showed before. Diffusers with HEPA or ULPA filters, high efficient filters that eliminate all the particles. We have our air ductwork, which is in a round shape or rectangular shape, normally made by galvanized steel, normally in tightness class C. They can also be fully welded, which means class D. Laminar airflow on the end, which is especially designed for operating rooms. So we will laminar airflow technologies minimize infections, microorganisms to enhance air quality and surgical site infections. This will be shown also in presentation later. Those are only the examples of the HVAC drawings that we prepare when preparing the design of the project. So P&ID, piping and instrumentation design drawings, schematic drawings of all the piping, heating, cooling, steam, city water, all different piping elements, ducting, process media, process piping, GMP classified piping, and air handling units. Those are just the example of the recently executed pharmaceutical project in Belgium. HVAC. So when we design, we need to be aware of potential collisions with other trades. If we are only offering mechanical and architectural part of the project, there might be some collisions with electrical installations or with utilities installations. So we need to make sure 3D model and reality are well monitored, and that we don't run into the problem in a later execution phase. We need to define access points for maintaining the equipment. There are static calculations of the supporting structures for the equipment on the roof, in the room. Those are all defined and prepared in agreement with the civil contractor, either civil contractor or general contractor or end user itself. It's also very important to define the positions of local exhausts, process exhausts, fire exhausts, and smoke exhausts. Here are some examples from of the piping and ducting that we made. Maybe here it's not needed to add anything else. So those are real projects done recently. Of course, every coordination is very important. General 3D drawing of the building we receive from the General Engineering Office, which is representing the client. Before installation, and then we have on the end of the project, we do the as-built drawings, and there are some deviations always, even if it's properly coordinated. We always have some deviations, so we need to monitor the latest status of the installations and put this into the 3D model, so we can hand over the drawings to the client. Here we can see the air handling unit systems after startup operation mode. Those are two films, videos, but you can see how the sections of the air handling units are assembled together. This is on the roof, and we have all the connections and piping and ducting then going down to the clean room. Let's focus on operating theaters, which we are strongly promoting in the Middle East and Africa regions, also in Europe, of course. Those are the pictures of our showroom that we have in our company's headquarters in Slovenia. What we can see here, it's a modular approach. It's a monoblock sandwich approach of the glass system from the inner side of the operating room, and in that case, galvanized steel from the outer side of the operating room, which then adjacent room is corridor. So this is corridor side and operating room side. So we basically don't need a substructure for our self-standing walls. It's ready to mount wall panels. So we are not delivering, we are delivering prefabricated elements, which are then easily put on floor track. We are not delivering substructure like maybe some other companies are. We have aluminum frame with rock wool insulation inside and a glass wall glued to the aluminum frame. This is all 3-in-1 ready to mount panel, which is delivered on site. And then it's we will see the video how installation manuals, how this is then put and assembled together. But this is fully modular approach that we have developed, and we are now doing some projects with this system of ours. We do not require building walls or ceilings. We have different solutions. We have cladding, one-sided panel or double-sided panel, which is in this case when we are trying to build the open space. All the cutouts for integrated equipment and appliances are pre-engineered, prepared in our production facility. Quality control is on a very high level. Every element before it is sent abroad. It goes through the quality assurance, quality control procedures, so we make sure everything is according to the expectations. It's very easy upgrade and low maintenance cost. So we can easily in between the walls we have silicon clean room grade silicon is one solution, or silicon gasket. So it means we can easily remove silicon and we can then install one panel. So, and we don't have substructure in place, which means we can really make the operating room larger, we can make it smaller, we can even demolish it and move it to another location. So nowadays there are plenty of requirements from the clients. So it's, in our opinion, it's good to have modularity to be flexible in that sense. Let's go. We can continue with our. You can see my catalog, modular operating rooms, right?
Not yet.
Not yet. Now?
Yes.
Okay. Modular operating rooms. We are basically involved in operating rooms, intensive care units, and central sterilization departments. Whereas operating room is the heart of the hospital. So we are putting a lot of focus in operating room especially. So what we do, our services are from the very beginning consulting, engineering. We do the 2D, 3D design with in-house engineering department. We have quite a big team of architectural and mechanical engineers employed in a company. So we develop 2D and 3D design, also visualization drawings on client's request and for the bigger projects. So client can really, or local distributor can really visualize how this OR will look like on the end of the day, on the end of the project. So we do the whole logistics, engineering, we produce, we have own manufacturing, we supply different elements like walls, ceiling, doors, and we will show also other one in next slides. We offer also supervision or installation, the whole installation of the operating rooms. Although our system has been developed to really simplify the construction process, so it's very easy to build it, to construct it, but you might need some support in the beginning, so we can easily offer installation supervision with our construction managers. Also here, coordination is of high importance. There are many other involved parties in a project. So beside our OR, operating room, capsule, fit out, we do optionally HVAC design. But sometimes it happens that we don't even do HVAC. This is done by somebody else, but we still need to coordinate with him and with the medical gas contractor, medical equipment supplier, civil contractor. So all these trades are involved in a project. So we have a lot of interfaces with each other. Here, maybe I would give a word also to our engineer Nates to describe a couple of technicalities about the systems we have. So Nates, please go ahead with a short description of different combinations that we have. Yeah.
Hello from my side also. So like Lucas said, we have various materials that we can apply and we can produce different types of panels. For the thickness itself, we can go cladding 40 millimeters or partition wall to side at 60 millimeters, in which you can install all the installation from medical gases, electricity, piping, and everything else. So basically, this gives you the variety of options. Dimensions are normally from 200 millimeters to 1 meter, and the height is standard 3 meters, but we can fabricate basically any dimension that it's needed for the project. So not really one panel, or let's say in every operating theater, we want to find as much standard panels, but there never is. So we are very flexible. It's tested for overpressure. It's tested to reaction to fire, which has A2 class. So it has good reaction to fire. It also has sound insulation tests to 31 decibels of difference. So the panels are tested, the panels are certified, and we have all the paperwork for it. Now, as for the materials, of course, the frame is aluminum. It is covered with 6 millimeter tempered glass. So for the cladding, one-sided. For the double-sided panel, it's two-sided 6 millimeter glass. And this gives the modular solution. So the panel, like the clean room panels, are made also for the operating theaters, which we are sole manufacturer for this solution. Every other company, as from my opinion, has a different approach, semi-modularity maybe, let's say, that uses substructures and other types of installation, which loses a little of modular meaning, because in our system, if you want to demolish one single panel in the middle of the wall, you demolish one panel. You don't need to go from one side or the other. You demolish one wall or one panel in the whole wall in the middle, and there is a opening in which you can use for carrying the materials, equipment, bigger stuff. So no substructure is in the way. So this gives you the 100% modularity. So the insulation is rock wool for the whole thickness of the panels, and from the back side, if needed but not mandatory, is galvanized or aluminum steel to close the panel. So like I said, that can be also with or without this galvanized sheet, but the same idea of the cladding. Luca, can you please just move the slide?
Of course.
Then, like I already mentioned, you can have two-sided glass panel, which has the same tests, the same materials, just two-sided glass or different material, which will come right now. It can be applied on this panel. Can be applied HPL, so pressure plates. We can apply Corian or Kerok or basically any different materials, which comes with 4 to 6 millimeters of thickness. So there's a very wide range of possibilities as for the materials. Also the PVC plates, antibacterial is possible to install with the same type of materials inside. The only difference about those materials are that the sound insulation, of course, reaction to fire, because if you apply a PVC, of course, you cannot get A2 reaction to fire, but you get a little worse. But of course, this is known in advance. This is not hidden, so everything is totally clear. But everything else is sound installation or other, let's say, pressure tests are the same as the other materials. So we achieve very high results. Then we can have also double, like I said, double HPL sided or different materials. We can also do, let's say, one side glass, other side Corian. You say we can do one side HPL and other side glass. So everything is possible. Those glass panels can be also ceramic printed, so the digital print can be with ceramic colors. So any needed design or picture what the client needs, it can be done. Also, we can do this for the panels, HPL or stainless steel or galvanized aluminum. But of course, there's possibility, even though that we apply a special cover film, it can be scratched. On the glass, the digital print is on the back side of the glass, so basically you cannot scratch it, you cannot damage it. So it's perfectly safe. So that's also an option that you have some design on the walls. Luca?
Yeah, what I'd like to add is we are using 40 millimeters for the cladding and 60 for the double-sided wall. With the 40 millimeter cladding, the big advantage of that solution is the panel itself is very thin, so we are not while if we have existing brick wall or concrete wall, which we would only like to make the cladding on top of it. We are not using a lot of space. So since due to our 40 millimeter thickness, modular approach, when we compare the system to semi-modular with a substructure, this conventional approach, you have 100 millimeter thickness of the substructure plus 10 millimeter thickness of the glass, let's say glass, tempered glass. So it means we lose 40 or 50 millimeters of space because also the existing wall is not even, it's not straight. So we put a floor track maybe 1 centimeter up front, and we do the one-sided cladding where we don't require substructure. So we only lose 50 millimeter space all over the room, which others are losing 120, let's say, millimeters. So yeah, it's quite from the same room we get use of more. So this is definitely good. Mates, will you continue?
Thank you. Yeah. So in operating theaters, always there comes electrical and other sockets for which we can do the cut out in the panel itself, glass or any other material, or we can prepare the stainless steel panel in which the cutouts can be prefabricated in our production or done on site. The difference is why. If let's say the client doesn't know in the beginning where this location will be, and believe me, this happens quite a lot. There's not always projects really detailed. We can prepare the stainless steel panels in which we can cut the openings on site. So this is the thing that if you have glass walls, of course, in the glass, the opening is not possible, but in this panel, it can be. So there is also additional options. And the same panels goes for the medical gas, which normally the location is known, but still, if not, there's a possibility. Those panels are normally from 1 millimeter stainless steel, IC through 304, but optional also 316. It can be HPL, it can be all that materials that we already talked about. Everything what we are talking about today is fully flushed, so nothing is put out of the depth of the neighboring panels or elements. So everything is fully flushed. Then we can have also LED wall panel or LED stripe for the illumination of the room for better visibility of the surgeon when the operations are performed. So this is all. These are all the options. Of course, the thickness of these panels are a little bigger because in the back there must be some electrical installations, the housing, everything. So this is a little thicker than our panel, but also normally, or not all 4 of the existing walls are next to the brick or concrete wall which already exists on the site, like Luka mentioned. But one of them probably has to be a little pushed away. So all the installations, let's say control panels and screens and everything else must be, if you want to have it fully flushed, it must be recessed inside the wall. So the thickness is a little deeper with the thickness of the not only the wall but not only the panel but the wall itself. So let's say it is 150 millimeters, in which you say, okay, this is technical area. Inside we'll put all the gases and everything else. So the next thing that we also produce is sealing for the operating theaters. Normally it is used as galvanized steel. It can be also stainless steel, patent or not. This is always an option that you can choose. The panels are 60 by 60 centimeters, and they are totally removable. It's easy access to the technical areas, and in operating theaters this is a mandatory thing. Because from the above there's no option to come near the elements that you want to service. Okay,
I'm just jumping in, Nate, shortly. Yeah. So the difference between operating room ceiling and the pharmaceutical facility ceiling that we saw before, it's that in operating rooms we have non-walkable ceiling, so we don't need. We don't have this access just above the ceiling. You cannot walk on it. This is the normal standard solution that we use, non-walkable ceiling. But of course, if there is a demand, we could also use walkable ceiling, which we use in pharmaceutical.
So there, then one of the elements that we use in our walls are fully flushed workstations and control panels. But for now, let's talk with workstations. So different sizes of screens on which you can, like you see, they can be used for the X-ray photographs or other digital informations. So we have one Slovenian supplier which we developed this glass with these control panels with, but we don't use only one. So the variety of the elements are quite wide.
It's fully glazed, so it's again fully flushed, integrated in our modular wall system. It can come with a keyboard or without keyboard, so different options are available.
One similar element, but not the same control panel for the whole OR, on which you can basically work with every electrical element in the operating theater. So different sizes, again, 22 or 31 inch display, and on what you can see the basically everything: time, date, UV lamp, X-ray controls, then lighting, HVAC, humidity control. You can control the temperature, the air, basically, really anything that you need. Sorry, I guess.
You can monitor the medical gases that are crucial to be installed in a OR, so you can at any time you can see the level of gas that we have. So if it's within the set limits, or it run under or above the set values, so you can easily monitor and that, and you get an alarm if this runs out of the range that you set.
In the meantime of the moving slide, I saw the questions that you are posting. Please do that freely. We will attend to them in the end. Right now, we don't just stop the presentation, but in the end, of course, we will attend to all the questions. So thanks for the writing.
Yes.
Next thing, laminar airflow sealing. Normally, our product is stainless steel. It is 45 centimeters of height, so it's not very big. This is a plus, definitely, because the technical area in the sealing technical area, there's no room on any project. So this is definitely a plus. So, like I say, stainless steel, IC 304 class, of course, with HEPA filtration. It is done by this ASHRAE standards. It has the connections, the filters, saturation control. It can be done in a higher class of stainless steel. It's followed by DIN standard 1946-4. And of course, the dimensions can be different from 1.5 meter to basically 4 or 5 meters, 4 by 4 meters. It depends on the height of the size of the operating theater. So there's no limitations also on this part. So also, of course, this then connects with all the systems that Luca in the beginning talked for the HVAC. We can also provide this and the whole solution. Then we go with the sliding doors. It can be swing doors, it can be sliding doors. The thickness of the doors are normally 60 millimeters. Of course, there's different suppliers which you can use besides us. We can implement any item from the market, basically, that you would like, and we make it work. It can be hermetic or semi-hermetic. It can be full glazed or just from stainless steel. Normally it's stainless steel or glazed, but also it can be galvanized steel. It can be X-ray protected from 1 to 3 millimeter thickness of this lead. And of course with the window, optional with this shades inside. And the frames can be fully flushed again, or it can be over the opening of the doors, so the frame is, let's say, about 3 centimeters over the panels. So this is the only thing that it's not fully flushed, but still, if there's a demand, it can be. We have a solution also for the fully flushed doors. So the cleaning is totally the cleanliness and the walls can be cleaned easily. Of course, the other elements are exhaust grills, also stainless steel. I think we all know what this means. It has the G4 filtration included. It can be different brushing or polished stainless steel, different quality of the stainless steel, etc. So next, of course, LED ceiling fixtures. They are clean room grade, so IP65, service from below. It can be different color range, different power, different voltage. It can be DALI optional, RGB optional. Everything is basically possible, and they're very high quality lights, which are of course connected to the control panel. We can also provide, which is not our main thing, but of course in the whole solution, there can be also provide with we can also provide the PVC flooring, electrostatic or not, and all the other technical specs of the flooring itself. It depends on the wishes, like always, like every element actually. So this is quick presentation of the design, of the details. All 4 walls. Of course, the corners are 45 degrees panels. So the ventilation in the back, there's a ventilation duct for the extraction of the air. Everything else is fully flushed, like you see. The opening for the doors, the opening for the control panel, for the clock. Down on the left, you can see the stainless steel panels, which has the substructure behind in the panel, so you can mount the heavier equipment on the walls. And of course, the 4th wall is digital print of Como Lake, which we installed in our project in Riyadh, I think, Luca. Yes, this is from Riyadh.
Yeah, Saudi Riyadh, correct.
This is how the designs are prepared, or 2D or 3D, depends on the wishes of the client. Then we send it to the client to approve them before production.
Yeah, so all micro locations
happens without the confirmation.
Yeah, all micro locations of the medical gas connections and electrical sockets needs to be aligned, coordinated. So yeah, then we put them in our drawings, and then we send the drawings to the client for approval before launching the production.
So the different construction details, like we talked, cladding or partition or a technical area. So the first on the left, it's cladding. It's one-sided glass, HPL. It can be other materials. So don't focus just on the materials that they're written here. There's all possibilities, so that I don't mention them every time. So the first one is cladding system. The second one is partition, two-sided from one to the other room. The third one is this technical area that we're talking about. We can basically make it from 5 to 1 meter, 5 centimeters to 1 meter. It can be as big as the person goes inside, so the panels are not demolished from the operating theater side. So the walls are always intact, they're always on their location, and from the other side, from the outside, there are basically the doors to enter this technical area. So there can be different dimensions in between to put inside monitors or pass-through boxes or installations, etc. And the last one is this one, like I said, service corridor, technical area. So cladding and partition wall. As for the construction details, it's the same like we already said. It can be partition two-sided or cladding one-sided. Of course, everything is on the floor guide, which is leveled first, and then all the panels goes on this floor check profile, so it is perfectly leveled. And the detail about the and here I can see on the first picture it's already written 40 millimeters. This one can be 40 or 60 millimeters. The cladding itself, the second one, can be only 40 millimeters because you don't need to lose any room, any additional space in the operating theater.
And the floor guide and the floor track is also not only 50 millimeter height, but it can also be 100 millimeters. So we have different clean room flooring radius when we are doing, if we are doing the flooring.
Yeah. As for the detail of the ceiling, it can be finished. The joint between those two elements can be finished with PVC or aluminum coving or without. It depends on the demands, but of course, also on the ground, on the floor, it can be without the floor check profiles. Let's say you have epoxy flooring, not PVC, so it doesn't need to go up on the floor check profile. We can put the panel directly on the floor and siliconize the joint. Not normal solution, not even close to normal solution, but there's an option, and we already had to use it, so we are flexible. Okay, now maybe Luca, you take over.
Yeah, let's just mention for shortly that we are also equipping, furnishing the all not only operating rooms with the stainless steel furniture, but also ICUs, NICUs, CSSDs, patient recovery areas, and clean corridors with different furniture elements. So all the closets, wardrobes, doors, or claddings. So example of some of the projects that we did. Here, pharmaceutical. You can see the pharmaceutical furniture in the locker areas, in gowning areas, sit over benches, pull out closets, so shoe cabinets that we can produce, manufacture on our own, and also wooden part, as I said before. So we have here several examples of recently executed projects. This reception desk is made of Corian. We have here wooden furniture in a private clinics and a small surgery centers. In ICUs, as you can see here down on the pictures, we also supply stainless steel cabinets, building cabinets of stainless steel scrub sinks for surgeon preparation areas, scrub areas. So you can see that on the picture below, right? And here on our corridor side, so let's call it like non-clean room area, CNC, we use wooden profiles, wooden claddings, and some other wooden parts of the furniture. And here are pictures from our from executed projects in Saudi Arabia. One project with 2 operating theaters in Riyadh. It was a private clinic and with a dark blue color left above, and with a light blue color in Jeddah. 4 operating theaters. It was also for a private client. So we supplied all the glass walls, integration systems, control touch panels. So not only painted glass, but also every room had its own motif, which is digitally printed on the backside of the glass, like Nate's mentioned before. Building cabinets from the stainless steel, exhaust grills. Doors in that case weren't supplied by us. We just they have been purchased locally, so this is not our product in that case, but we can also offer doors, of course. We delivered laminar airflow ceiling, which you can see on the bottom of the ceiling. What was not in our scope is some medical equipment, so all the pendants, all the surgical lights, and operating tables. This was purchased by the customer directly. So we went through. I'm trying to share our PDF back. if this is going to be possible. Can you see that?
Yes.
Perfect. Here on the video, you will see the simplicity of our modular system. Those panels are, of course, as a samples. Normal standard panel width is 1 meter and the height is 3 meter. Those are only smaller samples to show the installation manuals, but that you know that we normally have, yeah, of course, 1 on 3 meter height panels. Let's see how this is done.
Video is not visible, Luca.
Sorry?
Video is not seen. Video is just a picture. Try to share the screen.
You can see it now.
Yeah, no, it's moving, yeah. So I will take over because there's no sound also, some technical issues. So there you can see the floor track profile, the longer profile, this one. These are connection profiles for the connection between the floor track and the panels. But between the panels there is smaller profile which gives the panels modularity. So it doesn't connect them. It can be also used on the wall, but normally it's not. So the system doesn't lose the modularity to demolish. So like I said, these panels can be connected with the same tubes, but then you lose the purpose of modularity, but you gain the strength of the wall. So it depends what you need, what you wish. We have all the solutions. You just connect them. We like to joke like big Legos. So you see the joint is 2 to 3 millimeters of width, wide. So it's filled with silicone, clean room grade silicone, which is all certified and accepted. On the other side, you can see, let's say, 2 galvanized steel sheets, or the combination of 2 different materials, which is still fully flushed. Inside of this gap, if needed, can be installed also the installation hose, this plastic to use it for the electricity. If the electricity doesn't come from the behind, for which we make an opening in the panel itself. So basically this is how easy the installation is. Like you see, the panels are not fixated and they're standing on their own. The same is on the side.
Yeah, thanks, Nate, for, I don't know why the sound wasn't working, but nevertheless, yeah, so as you can see, this is very modular and it's like a puzzle. So you just put really one panel next to each other. You connect it with a tube profile 20 on 20, which then, yeah, make it semi-modular, or you use the 10 millimeters on 20 millimeters profile, which then gives a full modularity. And it's very, very easy to build this in a short period of time. Okay, maybe for the furniture, can you see this catalog now?
Yes.
I will just mention it shortly. So as I already did before, we produce medical and non-medical furniture, loose furniture, not fixed furniture, not the chairs and the sofas, but the fixed furniture. So actually, we have many apartments, many houses, hotels, offices, villas, where we use the wooden furniture. We do also the Kerok stainless steel elements. So those are only just a few examples of what we manufacture and deliver and install. Those are all we collaborate with many engineering offices to find a suitable solution for the end client. So here just I'm running through it quickly. So those are all the projects that we did. And of course, if we focus on a medical furniture, which is today's session major theme, like I said, furniture for a healthcare, pharmaceutical, and lab facilities. So we use HPL materials. We do the glass claddings even here, not in OR only, and we furnish all the critical sectors within hospital. Those are some of the pictures are the same that I've been showing before. Here on the right, you can see the pharmaceutical HPL furniture. You can see laboratory here underneath. So it's from HPL and normally melamine face chipboard with HPL combined. So that's basically it. And you can see my PowerPoint again, right?
Yes.
The standards and certificates that we are following during the design, engineering, and then implementation phase are ISO 14644. It is European standardized, international actually standard for clean room and associated controlled environments, which includes pharmaceutical and healthcare facilities, GMP, good manufacturing practice, FDA, which means Food and Drug Administration, American standard, ASHRAE, American Society of Heating, Refrigerating, and Air Conditioning Engineers. We are following technical guidelines, DIN German standard 1507 for ventilation in the buildings, and ISO 14056 for laboratory furniture. Not only our product range, not only products have certificates and CE declarations and test reports from the third parties, notified bodies, but we as a company are also certified with different standards. So that means that all the processes within the company are in accordance with ISO 9001, which is a quality management standard, ISO 14001, which is environment protection. So all the processes are protecting the environment as well. So we are all circular and sustainable oriented. We also have ISO 45001, which is safety and healthy at work. So this is very important for us. All the big multinational, especially pharmaceutical companies, are requesting to have this in place. And we use ISO 3834, which means which is the welding procedure. So different parts of our either furniture or walls or different other modular system elements are welded. So we also have this standard, and we are A++ gold credit worthiness rated from the Dun and Bradstreet company, who is evaluating the credit worthiness internationally. So,
hello, Mr. Lucas. Sorry for interruption, but we have only 10 minutes left, so I guess we can start taking over questions. Yeah.
This was just the case now, so I'd like to thank you for your time. Hopefully we will have the chance to collaborate. Yes, please go ahead with all the questions that you might have. We are now, we went through, yeah. So
okay, now I'll take over. Thank you. So the questions from the beginning. If we need to prepare a budgetary offer for modular OR, what are the main parameters that can affect in the price? So basically, everything affects the price. Materials, definitely materials. The range from galvanized sheet and digitally printed glass is nearly doubled. So the prices here can be very wide, but again, the panels itself are the smallest portion of the cost of in the operating theater project. So again, it is a big difference, but it's not, because let's say the whole operating theater panels can cost, for instance, 20,000 euros, and one pendant costs 30. So it's not so big of the size of the project. So what can affect? It can affect the materials, can affect the size, can affect the what kind of equipment in the operating theaters you need. If you need DALI and then RGB lights, they are also 40-50% more, and etc.
Yeah, correct. And in addition, structural elements. I mean, with the structural elements, wall, ceiling are really as Nate mentioned, are not. They are a small part of the overall costs of the investment. So medical equipment is definitely one important factor. And doors, automation for the doors. This can vary a lot.
Yeah.
Whether we have it or not, or do we have a normal classic OR or hybrid one which needs the LED protection?
Exactly, LED is very expensive. Even on the windows in the glass, this is a big difference.
Yeah. So, and the class of the operating room, whether is it 1A, 1B, depends. If we decide to go with the higher air change rates that I've been mentioning in the very beginning of the presentation, this can, the HVAC system is very complex, so this is where the costs can be pumped up or saved on the end of the day. So.
Okay, so I hope we answered. If not, please add additional question on this matter. So to the next one, if we have a problem in HEPA filters in laminar flow at OR, how can we check it? So every laminar flow unit has, how do you say, Luca, this
differential pressure sensors.
Yes, thank you.
Yeah.
And you can connect the laminar flow unit before the HEPA filters and after the HEPA filters, so you can control the how dirty they are and how much air goes through them. So it is controlled by this. In every clean room actually is the same as here.
Yeah. So after pressure drop on the HEPA filter is around, let's say, 300 or 400 pascals, then it means that it
has to be changed.
It has to be replaced. It has to be changed.
Yeah.
And that can easily be done then during the maintaining period in a hospital.
Mm-hmm. Okay. So next question. Some rooms as medical waste, a room need temperature with 16 degrees. How can we achieve it from HVAC?
I mean, with a complex HVAC system, everything can be achieved. This is simple as that. So we just need to be aware that bringing down the temperature to 16 degrees from the normally it's 18 degrees, 19 in the operating theater, in the clean room, other areas is 21 plus minus 3 degrees Celsius. It means that we need to
install additional chillers.
Additional chiller kilowatts capacity that will enable us to bring down the temperature. So this can all be managed. It's all just related to costs. Then, so this is not the problem. This needs to be designed and achieved.
Yeah. So stronger unit and some additional elements if needed, and everything can be achieved. So next question, how can we calculate the area of AHU room? So basically the engineer, not the engineers, but the project company, the company who does the projects, they calculate by the standards. We also use their information when we design the operating theaters. If we are doing this, then we have our own people who, by the ASHRAE or other standards which we have to follow, we give them the information how big the rooms must be, according to your demands of how big the let's say the clinic or the hospital is. So if you say we need 200 beds, we will say, okay, you need 3-story building. And then we will go to the details about the square meters and everything. But if you only are talking about one room, there are standards that you have to follow. And this is all demanded here.
Yeah, that is all defined in of course, in URS, user requirement specification, and a room data sheet, which mechanical engineers are preparing. So based on that, we know the capacity of cubic meters of air that needs to be supplied every hour for the whole building or operation block only, which supplies only the operating theaters. Then with the technical data sheet, we define how big this air handling unit is, different of the sections that are inserted. So then we just know how big actually air handling unit is. So then we need to see where to put it on the roof or in the technical area, which is then inside the building. That needs to be but coordinated in advance in early stages of the project.
That's correct. So the last question, what is the additional preparation in modular operating theater for hybrid OR using MRI or CT? So this is 2 different types. One needs stainless, one needs steel, how to say, Luka Kletka.
Cage.
The cage, yeah, it needs the steel cage, and the other one needs a leaded cage. So basically those two are the only things that cannot be inserted in our modular system. Why? Because it is too heavy and it's too complicated, and in either way you lose modularity. So the LED and this Faraday cage must be put behind the wall. So you put the LED or the steel on the substructure on which we then put our cladding walls. So here the cladding is mandatory. In that, it's always in all the projects it is solved like this. So there is additional layer of material behind our cladding.
Correct.
So for now, these are all the questions that they were. So if there's no additional ones.
Yeah, I hope that you received the information that you were searching for. Is there any other question at this stage? Please feel free to ask.
I guess that's all for today.
Okay, that's fine also.
So from my side, thank you for the participation to the course or to this presentation. So
We actually would like to thank you for such a great presentation, such a great preparation, and we are looking forward to another collaborations together. So thank you very much for this rich knowledge, and we would like to thank also Mr. Luca and all the company for this great efforts.
Thank you, everybody who listened to our session. Hopefully it was interesting. We will organize another call, another session if needed, so to go even more in detail. So thanks for opportunity, Mr. Ali, Mr. Karim, also to having us here. And if at any later stage any question arises, please feel free to reach out. So thanks everybody for your patience and time.
Of course. Thank you very much. That's our pleasure to have you today.
Okay. Have a nice day, everybody.
Thank you very much, Mr. Luca.
bye.
Bye.
Have a nice day. شباب هبعت لكم الفورم دلوقتي بتاع الفيدباك، ما حدش يطلع قبل ما يسجل علشان بإذن الله الشهادات، وكمان نعرف مين اللي حاضر.
مهندس كريم ما تنسانيش في الشهاده بعد اذنك.
اكيد طبعا باشمهندس عادل. الشهادتين اللي فاتوا معلش زاغوا مننا معلش.
عامل ايه بس معاك يا باشمهندس كريم؟
خطأ مطبعي مش هيتكرر.
محاضره ممتازه جدا ورائعه بصراحه، وفيها معلومات مهمه جدا خاصه بالاتش باك كمان، ممتازه جدا.
هو ضاف حته برضو اللي هي اللايرز، ان هو ممكن يضيف لايرز من عنده سواء ليد او ايا كان، عشان حته برضو الهايبرد دي برضو كانت حلوه يعني بصراحه.
هو السيستم بتاع المودولار او ار هو سيستم حديث بيدي مور فلكسبيليتي في التعامل مع الغرف، يعني زي الحاجات اللي هي الكونستراكشن الموفابل والحاجات المتحركه. فالمودولار او ار الحديث بيحصل فيه تطورات بطريقه سريعه، وفي نفس الوقت بيديله فلكسبيليتي زي ما بيقول لك كده في الميديكال جاز، في الكهرباء، في الليد اللي بتتحط في اللايرز اللي بتبقى موجوده ورا الحيطه. يعني الاول لما كنت بتحطها على الحيطه العاديه هتحتاج تحط رصاص، وبعدين تحط على الرصاص يعني شكل تاني على اساس تمنع الانفكشن. فكان الكلام ده بيعمل اجهاد شويه على الحوائط وبيبقى فيه شويه مشاكل. امال مع المودولار او ار لا، الموضوع بقى فيه مور فلكسبيليتي ومور يعني. طبعا كمان الاشكال الجديده من نظام الجلاسز ونظام الاشكال اللي بتدي للدكتور رؤيه كويسه ومنظر كويس جوه غرفه العمليات غير المنظر التقليدي. ده يعني بيدي شويه في النفسيه بتاعت الدكتور في الشغل، يعني بيدي يعني فيدباك كويس للدكتور وهو شغال يعني.
هي الريكوردز دي هتكون معانا؟
اه طبعا، هي الريكورد دي كلها بتتسجل، بنرفعها ان شاء الله على على القناة بتاع اليوتيوب، وبرضه بنرفع اللينك بتاعها على الويب سايت بتاع البايوريكس. فبإذن الله أي سيشنز عملناها أو هنعملها بتكون على القناة بتاعتنا بتاع اليوتيوب.
طب ممكن لينك القناة؟
أكيد. معانا في جروب الكوميونتي ولا؟
ولا بعتلي الحاجة حد معايا في الكلية بس
أوكي.
جروب اسمه بايو
خلاص
هيليكس.
خلاص، أنا هسيب لكم برضه لينك قناة اليوتيوب في السيشن هنا في الشات بوكس.
تمام.
ممكن كمان يا باشمهندس كريم بعد اذنك، يعني لو نقدر نعرف من الشباب ايه اللي يعني يعني احنا طبعا هنعمل سيشن تاني في خلال شهر واحد زي ما بنعمله في كل شهر. ايه اللي الناس تتمناه في السيشن القادم يعني؟ عاوزين نغطي ايه في المعلومات او الانفورميشنز اللي موجوده.
هو ده كده كده موجود في هي الفورم بتاع الفيدباك، فأتمنى برضه الناس تهتم يعني بالسؤال ده، لأنه موجود أصلا في الفورم.
يعني احنا كل شهر يا باشمهندسين بنعمل سيشن مع حد من شركات انترناشونال خارجيه او حد من الناس الخارجيين. فاحنا يعني بنعمل السيشن بناء يعني على تصورنا. فلو عندكم انتم تصور لحاجه كويسه تبقى مفيده بالنسبه لكم، ممكن نتواصل مع الشركات ونعمل السيشن القادم على حسب رغبه الناس. ممكن استاذنك يا باشمهندس كريم ولا لسه؟
الناس برضه اللي بتسأل على قناة اليوتيوب، اللينك بتاعها سبته لكم في الشات بوكس.
باشمهندس كريم ممكن استاذنك ولا نستنى شويه؟
لا أكيد، اتفضل. خلاص كده يعني،
ماشي.
أعتقد
اه انا
الناس
كده
كلها خلاص.
ماشي يا هندسه.
خلاص أوكي.
السلام عليكم.
يلا، السلام عليكم.
السلام عليكم.
سلام.